Welcome to Sparks and Chips again. More specifically, welcome to Tamper Tuesday, which is our chance to void warranties on things and see what makes them tick. Today we're going to be looking at this pulse width modulation dimmer, which we picked up for $5 off of this, really get it quick website, which I'm not going to mention the name of it. But anyway, $5 seemed like a little too good to be true. So, we get this thing out and we look at it, and it's got markings on the front that say dimmer, off on, its approximate voltage and amperage, and where to put the wires on, but nothing else. No made in, no manufacturer's numbers, nothing. So of course we've got to take this apart and find out how many hamsters are in this thing, or whether it's just a big giant variable resistance rheostat that controls whatever it is you want it to control. The only markings on this, on the external part of the box, is actually on the terminal on the end. There are manufacturer's markings on that. So why is it important for us to check out and see exactly how this thing is made? Well, actually why it's important is, if it's just a rheostat, that's extremely inefficient for most of the things we want to use this for. If it's actually pulse width modulation, that is a very efficient way to handle lighting, motor control, servo control, a lot of different things that we would use electronically. So as we take this apart, we see these huge screw heads with little teeny tiny shanks, which seems odd at first, but then upon closer inspection, we realize that those large heads would prevent the lid from splitting out if there's any force applied to it, and the tiny shanks allow for automated equipment to insert the screw better. By the way, I'm using one of my favorite tools to take things apart with. I just can't tell you what brand it is because they're not paying me to do this, and I don't do anything like that for free. So anyway, but it is my favorite tool and I do enjoy it. Back to the pulse width modulation dimmer. This thing is really blank on the outside, so when we take it apart, I'm not sure what I'm going to find inside it. Pulse width modulation, as I've said, is very efficient, and for those that know how to use it and know what it's all about, it's really something to behold. As we open this up, we find a rheostat in there. I'm like, oh yeah, okay, here we go. But then I noticed the rheostat's actually connected to a teeny tiny circuit board held in place by two screws with a terminal sticking out on the end. Well, this is a bit of a surprise. And there's gobs of room around this. This may be a legacy box or a box that's used for multiple things with this little tiny, about the size of your thumb, circuit board in there. So of course we have to take the circuit board out and figure out what's going on with it. So we pull the screws out and the terminal just unclips off of the end of it. Very good design, to be honest. I was quite surprised at how easily that was to take apart. And then we get in there and we look at this circuit, and I'm really surprised at what I find. And what I find is a very well-built circuit, a very simple circuit, runs off of the old Texas Instruments 555 timer, which is your base timing unit to create the base pulses. It's got a dual op amp, also built by Texas Instruments, and this non-branded large transistor over to the edge, and that's actually the switch for this thing. Here on the right-hand side of the circuit board, the transistor acts as the on-off switch, and it switches very rapidly. We're talking about on the order of anywhere from 100 times a second up to the base timing on that chip is 100,000 times a second. And so you can have a myriad of different timings, and that's actually partially controlled by that rheostat. And it sends signals to this and switches it off very rapidly. So all in all, I find that this is a very well built, very simple, very inexpensive controller. Handles up to 8 amps according to the manufacturer marking on the front, which is all the markings you got, and also goes between 12 and 24 volts. So what else do? We put the thing back together, and I use it on my desk right now to control part of my LED lighting here on my desk. So far I'm very impressed with it. It's a great little piece. Didn't cost hardly anything. I'm tickled to death. Hey, you know what? This is our inaugural Tamper Tuesday. Thanks for joining us. Come back and we'll do more tearing up.